Maynard Smith pioneered the idea of using game theory to model that scenario. And game theory is basically the study of strategic decision making. And it's widely used not just in biology, but also in economics, political science, and in psychology. The idea behind game theory is that we can simulate the outcomes of particular strategies by playing them as if they were evolutionary games. The contestants, or the players in this game, are individual animals who can choose a particular strategy. So a strategy might be fight, or it might be display, or it might be run away. The consequences of a given strategy are measured as the payoffs of that strategy. And in the case of animals, that payoff would normally correspond to a gain in fitness. Maynard Smith developed a very simple game to understand animal conflict over resources, which is called the hawk-dove game. And in this game, animals that choose to fight are called hawks, while those that choose to display instead are called doves. So for example, if a stag had the strategy of hawk, it's willing to fight in order to have a resource. By contrast, a stag playing dove will posture a bit by roaring, but then back down if another one starts to fight. So, what happens when hawks and doves play each other in this game? Well, when a hawk meets a dove, the hawk always wins because the dove retreats. When a hawk meets a hawk, then there's a fight between them until one of them is injured. Assuming that they are usually evenly matched, then each of them has an equal chance of winning the fight, and so it wins about half of the time. When a dove meets another dove, they engage in a prolonged posturing exercise until one of them decides to give up and leave. Again, if we assume that each of them has about a 50% chance of outlasting the other, each dove wins about half of the time. Now, let's suppose that the animals are contesting a resource with a certain value, which we will call V. The winners get V, the losers get nothing. But let's also suppose that serious injuries that are inflicted by fighting hawks inflict a cost, which we will call C. We can now try and get a sense of some of the payoffs that come out of this game for the contestants. When a hawk meets a dove, it will get V, while a dove meeting a hawk gets 0. When two doves meet, the value of the resource is split between them, so they get the equivalent of a half V. And when two hawks meet, they also get half of the resource on average, but they also incur about half of the risk of the injury, and that reduces the value of the resource, so they get half V minus C. Let's try to see what happens when we use some numerical values to work out the payoffs. The first thing we have to consider is whether V, the value of the resource, is smaller or larger than C, the cost of injury. Now, in most contests in nature, it seems reasonable to assume that the value of the resource will be smaller than the cost. And that is because it'll rarely be worth risking serious injury from a fight simply to win an item of food or access to shelter. So we'll assign an arbitrary value of 50 to V and an arbitrary value of 100 to C. In practice, it doesn't actually matter what values you assign to V and C, the outcome is always the same if V is smaller than C. So what do we have? When a hawk meets a dove, the hawk gets 50, the value of the resource, while when a dove meets a hawk, the dove gets nothing. When two doves meet, the average payoff is 25, which is exactly half the value of the resource. The doves pay no cost. When two hawks meet, they gain on average half of the value of the resource, which is 50, but each also has to pay half the cost of the injury, 100, and the hawks end up with, on average, minus 25. Now we can see from the matrix that the maximum payoff occurs when a hawk meets a dove, plus 50 here. And we can conclude from that in a population consisting mainly of doves, the hawk strategy would have the highest payoff, because a hawk gains 50 every time it meets a dove, whereas doves can't do any better than 25. So in a population consisting mainly of doves with rare hawks, the hawk strategy will win. On the other hand, in a population consisting mainly of hawks, dove will actually be a better strategy to play. And this is because most of the hawks will be busy fighting other hawks and getting -25, whereas a dove losing to a hawk does no worse than 0, because it doesn't pay the cost of injury. What that means is that when hawks are common, the dove strategy is the strategy that wins.